So let's take a look at, if we're given this function, 3x minus 5 times 4x squared plus 7, all right, one initial strategy students try to use with this would be to take the derivative of 3x minus 5 and take the derivative of 4x squared plus 7, which, what are those? 3 and 8x. And then to find the derivative of f of x, they try just multiplying those together. Okay, so we would get 24x. The problem is it's not right. Okay? We can't just do that. We can't just take the derivative of each part and multiply it together. Okay? Let's actually look at this though. If we were to FOIL this together, we would get 12x cubed, right? 12x cubed minus 20x squared plus 21x minus 35. Okay? And what would f prime of x be in that case?
36x squared.
Good.
Minus 40x.
Good.
Plus 21.
Yeah. Okay? That is the correct answer. Okay? However, we don't want to have to FOIL it out every time. And especially, let's say it was 3x minus 5 to the 8th power times 4x squared plus 7 to the 5th power. We definitely don't want to have to FOIL that whole thing out. Okay? So there's got to be a better way. And that's where we come in with the product rule. Okay? Because even if we didn't have, even though these ones we could FOIL out, we may even have functions where we can't. All right, for example, what if we had the sine of x times the square root of 3x squared plus 4? Okay? You can't multiply, that's as simple as it gets. All right, so we've got to have a way to handle derivatives that are like that, where we have a product. Okay? So here we have the product rule. Let's take a close look at this, and then we'll redo the problem we just did using that rule. Okay? So, you got to be careful that you write neatly with this, okay? Because we use U's and V's, all right? It's like back when we did vectors, all right? U's and V's we use, you got to be neat, all right? But we're talking about a function f of x here that is the product of two functions, u and v, all right? And what this is saying is that the derivative of f, so f prime of x, is u prime of x times v of x plus u of x times v prime of x. Okay? In other words, the derivative of the first factor du with respect to x, so du dx, times the original factor v. Okay? So du dx times v plus the original factor u times the derivative of the second factor with respect to x. So dv dx. Okay? Now, I like to shorten it a little bit because it kind of rolls off the tongue and it's a little easier to remember. So I like to say f prime of x is u prime v plus uv prime. Okay? U prime times v plus u times v prime. So what does this mean? How does this work? Okay? If I were working through the problem that we were just looking at here, I would identify my two factors first of all. The first factor was u, that's 3x minus 5. The second factor will be v, that's 4x squared plus 7. Okay? And we already found the derivatives of these. The derivative of 3x minus 5 was just 3. It's not writing for some reason. The derivative here is 3. And the derivative of 4x squared plus 7 is 8x. Okay? So now, in order to find the derivative, I'm going to use our product rule. All right? So first of all, I've got u prime. U prime is 3. I've got to multiply that by the original second factor. That's the 4x squared plus 7. Okay? The pencil died, sorry, so it's a little messy.
Will that mean that's then like plus 8x times 3x minus 5?
Exactly, okay? I got the original first factor, that 3x minus 5. And I've got to multiply that by v prime, which was 8x. Okay? And we will go ahead and simplify this. So if I distribute the 3, I get 12x squared plus 21. I distribute the 8x, I get 24x squared minus 40x. Okay? And you'll notice here 12x plus 24x is 36x squared minus 40x plus 21. And that is exactly the same thing that we got after we FOILed it and then took the derivative. Okay? So, with a simple one like this, if you would prefer to FOIL it together and just take the derivative, fine. Okay? In this case, using the product rule really is going to take you longer than just FOILing it and doing the derivative. Okay? In other cases, though, it might be necessary to use the product rule, or it may be just, maybe not necessary, but faster. For example, here in this case, as far as time is concerned, it's probably about the same, whether you FOILed it out from the beginning and then took the derivative, or whether you do the product rule, okay? But let's use the product rule for this one, just for the practice, okay? So, what would we say is u in this case? What's u? Good, 3x squared plus 5x minus 7. That's our u. So what's u prime? Good, 6x plus 5. All right. What's v?
4x cubed minus 2.
Good, that's v. So the derivative is?
12x squared.
12x squared. Very good. So now we're taking the derivative using the product rule. U prime, switch to blue here. U prime is 6x plus 5 times v, 4x cubed minus 2, plus u, 3x squared plus 5x minus 7, times v prime, which is the 12x squared. Okay? So u prime v plus uv prime. We will go ahead and simplify this one, even though we have to FOIL a little bit. Okay? We've got a 24x to the 4th plus 20x cubed minus 12x minus 10. All we have to do on the second part is to distribute. So we have a plus 36x to the 4th plus 60x cubed minus 84x squared. And now we combine our like terms. 24 and 36 would be 60x to the fourth. (20 plus 60 is 80x cubed. We have a minus 84x squared. A minus 12x and a minus 10. And that is the same derivative you would get if you had multiplied that, expanded that out first, and then taken the derivative. We won't do it just for time's sake. Okay? Making sense so far?
I like it.
Okay? So now, here's where things start coming together. We have more complicated functions than just, polynomials multiplied together. Okay? We have polynomials multiplied together, but here one polynomial is actually raised to a power. Here we have polynomials multiplied together, or at one polynomial raised to a power, but the other is a radical function. Okay? So in these cases, we're going to have to use the product rule, but notice, because these are raised to a power, when I go to do v prime, what am I going to have to use? The chain rule. Okay? So in this case, u is x squared, u prime is 2x, v is x squared minus 2x to the fourth. It's this whole thing. So when I go to find the derivative, it's going to be 4 times x squared minus 2x cubed times the derivative of the inside, which is 2x minus 2. Okay? So now when we go to do dy dx, I have u prime times the original v, which is x squared minus 2x to the fourth, plus u times that whole v prime. So 4x squared minus 2x cubed times 2x minus 2. Does anyone see what we can do here? That's u, which is x squared, times the v prime. The v prime was 4 times x squared minus 2x cubed times 2x minus 2. What can we do here to simplify a little bit?
Oh, we can cancel out the x squared minus 2x.
Okay, we're not going to cancel out, we're going to factor it out. Okay, it's not a fraction, so we're not canceling, but we can factor it out, and that actually will help us get it simpler. There also is a common factor of 2x, right? Because you see this plus sign, and guys, this is going to happen actually anytime you're using the chain rule inside of the product rule. Okay, you're going to have some common factors. So here I have a common factor of 2x. I also have an x squared minus 2x cubed. They have 3 in common. All right? So all that's left of this first half, the u prime v, is going to be an x squared minus 2x to the first. Okay? I took out a 2x from the 4x, so now there's just a 2x left. And there's that 2x minus 2 left over. Okay? So if I simplify all of that, I get 2x times x squared minus 2x cubed times x squared plus 4x squared is 5x squared. Negative 2x minus 4x is a minus 6x. And that's it. Okay? We could simplify a little bit more if we wanted, but that's good. Okay?
So that's the answer.
That's our answer. All right? So here we had to use the chain rule within the product rule. Okay? So, it's getting fun now.
Wait until it's quotient rule with all of that.
Yeah.